Alright students, so today in fact we are going to be talking about triangular graphs. And triangular graphs are in fact very important mathematical tools which can also be present in different subjects as well. For instance, the geography and also the environmental science past papers, as you will see for the Caribbean Advanced Proficiency Examinations, you will actually see some of these graphs present. Now let us understand these particular graphs in particular. Now these graphs are associated with three sides. As we can see, a triangle has three sides. All right. Now this particular graph that we can see on the screen, basically these three sides are in fact associated with three variables. For example, we have on the left hand flank or the left flank one variable, the right flank another variable, and also the base level would also represent even another variable. Now, what is important that we should always bear in mind in this particular point, this particular slide or view or whatever the case maybe you want to call it, the arrows are in fact moving in accordance with the numerical change. For instance, look at the base level. From 0 to 100, look at the arrow. It is moving in that directionality. From 0 to 100, on the left flank, it is actually moving upwards. Then from 0 to 100, moving, well, essentially down, right, but following the numerical change. All right, so class, given this particular directional pathway of these particular arrows, we can automatically understand this is in fact referring to a clockwise numerical arrangement. We'll be talking about anti-clockwise later on, but pay attention to clockwise first. All right. Now, we have here the left flank, we have the right flank, we also have the base level. Now, individually, right, let's pay attention to the base level first. All right. Now, students, at the base level here, we can actually see that from 0 to 100, which runs from right to left, these green lines can make contact with these particular numerical values. All right. They actually make contact with them. But what is very important is that these lines actually form an angle to the base level. All right, so look carefully in the graph here, right? We are seeing these green lines in relation to the baseline value. And we can see automatically there is in fact an angle, 60 degrees angles facing the direction to which the numerical values are in fact increasing. So for each of these lines, all right, there is in fact a 60-degree angle in the same direction the numerical values are in fact increasing. All right, and that is very, very important to note. Okay, so let's pay attention to that. Now, students, we also have the left flank, right? And this particular left flank is in fact showing horizontal lines coming in contact with the actual numerical range that we should in fact be referring to. This range, which is from 0 to 100 here, is in fact associated with the left flank, and with respect to that, these red lines actually come into contact with them. Now, the same concept of the 60-degree angles do in fact apply from the 0, which is the simplest or the minimal value, all the way up to 100. Let us look at this quickly. All right, so basically, right, the two lines that we are taking in consideration is in fact the 0 to 100. This view here, right, as you can see, the arrow is in fact pointing upwards in that ascending order. All right, but pay attention also to the fact that there is in fact a 60-degree angle between the numerical line and also the red lines, and that is actually very, very important. There must be a 60-degree angle there. All right, so you must take that in consideration all the way up. All right, so that's the reason why for graphs, triangular graphs such as these, right, we must take into consideration these horizontal lines are associated with the left flank for graphs which are associated with a clockwise numerical arrangement. All right, students, let us look at the right flank for a minute, right? And this right flank, we should in fact be able to take into consideration the same concept would apply. For example, from 0 to 100, this particular line is moving that way. All right, so the numerical line is moving down, but there must be an angle, right, of 60 degrees with respect to the line of interest. As you can see, 60 degrees exist here, 60 degrees exist here, 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 all the way down. All right, so this 60-degree line is in fact is in fact very important, because 60 degrees, right, as well as 60 degrees on each side, whether it be the right, the left, or even the base, all of them will add up to 180. A triangle actually has 180 degrees angle. All right, so keep that in mind. All right, so basically these angles that I'm referring to exist, right, between, or I should say it exists in that directional pathway in the numerical ascent. All right, so the lines which basically come into contact and intersect and create that angle to the baseline value or the numerical value, that is in fact the line that we are actually taking into consideration. Now I'm going to give you an example. All right, students, so what we have here is in fact a unique example. All right, for instance, let us begin by talking about the sides. Assuming this side is representing sand, this right side is representing silt. All right, and the base level is representing clay. And these values are in fact out of a percentage. This is soil sample A. Let us refer to the red dot as soil sample A. Now, before we understand anything else, we should bear in mind that from 0 to 100, this is the arrow, the directionality of the numerical values. 0 to 100 for silt, look at the arrow there as well, and the same thing will be applicable to clay. So we can automatically bear in mind that this is, in fact, a clockwise numerical arrangement of a triangular graph. Now, let us understand exactly what we did. Now, like I indicated earlier, let us talk about sand, all right, silt, and then we have clay. We have to understand what is in fact, these are the three variables that exist that is represented in this particular graph. Let us determine the values. Now, let us begin by talking about clay. This line is directly related to this base, and as you can see, this is the direction of the clay, right, given the arrow. Sorry about my little scrappiness. All right, this is a 60-degree angle, so we know we are in fact going correct. So this actually corresponds to 40 degrees. Clay refers to 40 degrees. For sand, right, this is in fact the line here. This is the direction of the existing numerical values. There is a 60-degree angle between them. So the sand percentage is also 40 degrees, 40%, sorry. If I said degrees, I apologize. I meant percent, okay? All right, and for silt, all right, this is in fact the direction of the numerical values. Look at the arrow, and we automatically know it is referring to this existing line. And the 60-degree angle exists here, rather. So this is actually related to 20% in terms of silt. So this soil sample A, right, out of 100, let us make sure we are actually doing the right thing. It has 40% sand, 20% silt, and 40% clay. In total, 40 and 40 is 100. 40 and 40 is 80, my bad. 80 and 20 is in fact 100. So percentage is also out of 100, really. So this is like a little proof to show that the soil sample is in fact correct, or the technique was in fact correct. All right, so soil sample E had, just to reiterate, 40% sand, 20% silt, and 40% clay. All right. Okay, now students, I want to talk to you about something with respect to the anti-clockwise numerical arrangement of triangular graphs, which would in fact be totally, well, not say totally, but would in fact be different, right, in terms of the manner in which we derive, right, these answers. It's the same concept applied, but slightly different. All right. All right, students. So what we have here is in fact an example of an anti-clockwise numerical arrangement. Let us make sense of this now, right? Now, based on what we can see here, right, we see in starting from 0 to 100 on the right flank. All right, this is the directionality of the numerical values. 0 to 100 on the left flank. Look at the direction. And also we have 0 to 100 on the base level. So automatically we can see, given the arrows, this is in fact associated with what? Anti-clockwise numerical arrangement of a triangular graph. Now that being said, let us see if we could give a value to a specific parameter here. Now look at the graph, you can actually see we have soil sample B. Assuming this side, which is in fact the left side, I should say, I shouldn't say this or whatever, but the left side, assuming this is say clay, all right, obviously these values would represent in the form of a percentage. The right flank will be associated with silt, and the base will be associated with sand. So we have clay, we have silt, and we also have sand. Let us determine these values, all right, based upon the location of B, all right, which is a soil sample. Now, all right, so what we can see here is that the direction of the values from 0 to 100 for sand is in fact from left to right. So the line that we're referring to is here, right? This line on the base level that we are referring to is right here. It actually makes contact with 20%. All right, why is that? There is in fact a 60-degree angle in that particular direction, which is an ascending order. So what do we know for sure is that the percentage of sand in soil sample B is in fact 20%. All right. What about soil sample, what about silt? For soil sample B, what is in fact the value of silt? Now we are in fact moving in that ascending order, which is from the 0, which is here at the base, and we are moving upwards. Now, this means that the values are in fact increasing, and we should actually understand the value of silt for B will be related to this particular line, all right, which is at 50. And the question is why? There is a 60-degree angle with respect to the numerical line. All right, and this being said, the value for silt, right, the concentration of silt or the percentage of silt in soil sample B will be associated with what? 50. So silt will be 50%. All right, and the same thing will also be applicable to clay. All right, look at the values. They are in fact running from 0 all the way down to 100. Look at the direction of the particular arrow. All right, now the line that we must take into consideration that is linked to this particular numerical line is that of B, this line right here. 4B is this line right here. All right, why is that? It actually forms a what? A 60 degrees angle, right, in that particular directional path. So the percentage of clay for soil sample B would in fact be 30%. All right, let us check over to see if we have this correct. If all the values add up to 100%, that means we are in fact correct. And 30 plus 50 is 80. 80 plus 20 is in fact 100%. All right, it adds up to 100%. So class, it doesn't matter if we are referring to anti-clockwise numerical arrangements of triangular graphs, or if we are in fact referring to clockwise numerical arrangements of triangular graphs. There are many ways in which we can work it out. You just have to understand two things: the directionality of the numerical values, all right, as one, and you have to also take into consideration the angle that would exist between the lines of interest. All right, so I hope this video was useful. If there are in fact any questions, feel free to let me know. All right, students, you all keep good. Wait, oh, one more thing. All right, students, I really apologize for one thing. One is stuttering, and two for the little untidy and little crappy foot writing somebody all over the screen and whatnot. All right, so just any questions, you can feel free to let me know. You could actually email me and whatnot, and I could clarify and whatnot. All right, you all keep good. Bye.